Hello everyone, welcome back to Altium Academy. I'm your host, Zach Peterson. Today, we're gonna be answering a viewer question about our classic 1-minute design review series. Now, unless you've been living under a rock or you're just not subscribed to the channel, then you probably know about the 1-minute design review series. Tons of designers have been sending us so many great designs, and we got a great viewer question about these design reviews and what really makes a great design review submission. Let's go ahead and check out that viewer question and get started. Now, the 1-minute design review series contains reviews of PCB designs that have been sent in from designers all over the world, and I'm so happy and privileged to be able to review these and show them on the Altium Academy channel. We've seen some really great stuff, a ton of ESP32 designs, you all know how I feel about that, and a lot of other unique designs, and it's really been a learning experience for me as much as it has for the audience. But recently, we received a really great question about the series itself and about the submissions. Let's take a look at that question. This question comes from the recent design review we filmed for Joshua Anthony's 60-volt battery management system PCB, and this question comes from Justin Shado. Justin writes, "Might exist, but is there a video covering all the things that make a truly excellent design review submission? I recall data sheets, BOM, clearing DRC errors. Why are these so prevalent?" being mentioned in these great reviews. Also, thank you for the reminder to add Silkscreen polarity indicators. Justin, this is an excellent question, and no, that video doesn't exist, which is why we're here filming it right now. What I want to do now is run over some of the designs that we've reviewed on the channel, and we reviewed over 100 at this point, so unfortunately I can't go through them all, but I pulled out a few that exhibit some of the common good things and bad things that we see in the design review submissions. So let's hop into Altium and take a look. So first, let's take a look at this design from Sohail Shabafruz. This is the first design that he sent us to review, and he sent us a PDF because I don't think he had permission to release the full design archive, but hey, at least he sent us a PDF, and it really illustrates some great things that you can do in the schematics. Now, first things first, we have a cover page with an image of the PCB taken from Altium's native 3D view. We have a table of contents here. We have some other design notes. Really great organization overall on this set of schematics. Now, it's 9 pages, including a block diagram, the cover page, and then we get into some circuitry by the 3rd page. You can see how good the organization is and how consistent everything is with these schematic symbols. Now, as I scroll through here, eventually we get to a power sequencing page. This is another thing that you can include in your schematics, which of course doesn't get used in the PCB layout, but it's a really great piece of documentation to include in your electrical schematics because it is part of the electrical documentation for the device. So here we have power sequencing, and we've seen some other examples of this type of documentation inside schematics in other projects. And finally, we have a revision history. Again, not mandatory, but this is something that you will see in project documentation. And of course, because schematics are the root source that determines everything that goes into a PCB layout for a given revision, it is important to include that revision history somewhere. And I think it makes sense to include it as one of the schematic pages, as you can see here in this archive from Sohail Shabafruz. The last thing that we see in these schematics that really shows the level of consistency and attention to detail is we have a consistent title block on all of the pages, and we even have page numbering. Good job on this. So this title block tells you everything you need to know about which page you're on, who was involved in the design, the company that has the ownership over the design, etc., etc. So that's all really important to include. A lot of times we see schematics that just have the basic default title block from Altium, or maybe they used one of the default Altium templates to create the schematic sheet, and it includes the Altium title block. You're free to do that, but I always encourage people to develop their own title block, whether you're doing it in the PCB doc file or whether you're doing it in the schematic doc file. It should contain consistent information. So make sure to go out and create your own schematic templates to use for the designs that you work on. Next, let's take a look at another example. This example comes from Xavier Emmanuel, and here's another good example of consistent documentation and, of course, very good organization in the schematics. So here on page 1, we have a block diagram. Now, this is not a hierarchical design, but in some ways, hierarchical schematics can also function as a block diagram if you're able to keep them clean. And for really complex designs, that can be pretty tough. But here we have just a flat set of schematics, and we have a pretty good block diagram. And one thing I like about this block diagram is, of course, it lists right here the signals that are going between the different blocks in this system. As we click through some of these other schematic sheets, you can see here that there's also a power tree diagram in page 2. I like that. You need to have a power tree diagram somewhere for your documentation or your specification. Makes sense to include it in your schematics, and that also helps someone like me when I'm doing a design review. When we go to the other sheets, you can see here, again, we have really great organization. We have a sheet specifically for the STM32, its reset pin, and then a couple of connectors that you would use for debug and programming. Going through here, you can see we have our Ethernet page. It makes sense to put the connector for the Ethernet PHY in the same sheet as the Ethernet PHY. You can see we've done that here on this page. Here in the motor driver, you can also see we've done essentially the same thing. The connector for the motor driver is in the same page as the motor driver circuit, and so on and so forth as we click through some of these other pages. Now, everything I just mentioned deals with the organization of the schematics, which is really important if you're going to have your design reviewed by a peer. But what about the actual contents of your CAD models and your schematic symbols? Let's take a look here in this same design from Save Your Manual. Now here, as we click through some of these components in this schematic sheet, you can see here that we have a few important parameters that I point out in a lot of design review submissions. One of these parameters is the manufacturer part number, and then another one is the manufacturer. Now, it's really important to include that information somewhere for all of your parts. And the reason should be obvious. You want to make sure that if you're doing a BOM export from your Altium schematics, that you pull the manufacturer name and the manufacturer part number into that BOM. And the fastest way to do that is to set up an outjob file and have the outjob file point to those two parameters for inclusion as one of the columns in your BOM. Now, you don't have to literally name this parameter manufacturer part number. You could name it MFG part number, MFG PN, manufacturer PN. We've seen all sorts of variations, and really any of them is acceptable as long as you're consistent. Make sure that if you use manufacturer part number on one of these components, you can see here it's used on all of these other components that I've clicked on so far in this design. So make sure you enforce that same level of consistency that you would enforce in your title block and all of your other documentation in your schematic symbols. Now, as I click through some of these components and I look through some of these other sheets, you can see here that in the properties panel, there are some other parameters listed in each of the parts that are certainly useful, but aren't mandatory for sourcing your components. Manufacturer and manufacturer part number are good enough to go into pretty much any procurement system, upload your BOM, and very quickly create orders. You can also do the same thing from Octopart. If you go to octopart.com and click on the BOM tool link, you'll be able to upload your BOM export from your Altium project. And from there, you can create carts on a distributor website where you can then make parts purchases. Some of these other parameters that are helpful are the case and the package. Of course, it's very nice to know that this CH340C component is an SOIC 16. And then you can see here we have some supplier information. So for example, we have a desired supplier that we've chosen here. It's LCSC. And then we have a supplier part number. And then we have an alternate part number listed here as a parameter, but of course there isn't one chosen at this time. So all of this is very good for creating your schematic symbols, and I think that's one of the things that makes a great design review submission. Now let's jump over to this other schematic from Tiga Nagraha, and we can see a few other things that I think make a great design review submission. Here, we only have one schematic sheet in this project, but if we scroll in and we just take a look at some of the characteristics on this schematic, you'll see a few things that make a great submission. So here we see, again, consistency in our net naming format. As you can see here, here for everything along this gigabit Ethernet connector. Here you can also see for these resistors, we're actually showing the value of the resistor in a comment. Very good. So that comment is visible in the schematic. And then here you can see that this comment is keyed to a value that is specified as one of the parameters here in the properties panel. Same thing with these capacitors. The value of the capacitor is visible. I don't want to have to then click on this capacitor, grab the part number, put it into Google, and look up what the value of that capacitor is. Next, on these differential pairs for our USB interface, we've used the differential pair directive. Very good, because they do need to be routed as differential pairs. And in order to use the differential pair routing tools in the PCB editor, you have to assign the differential pair directive to these nets. Another thing that I've liked here is that we've used nets that very closely match the pin name on some of these components, which makes a lot of sense too. And using nets that match the pin name is very nice because sometimes in the PCB layout you will see a net name and it's not always clear exactly what the function of that net is. But hey, assigning these names to nets, even if the only place they go to is just one of these pins on this component, is very helpful for understanding what that trace is doing or what that signal on that trace is doing and where it is connected to in the design. Finally, a really good practice on all of these integrated circuits is to include the part number for the integrated circuit as a comment, and not just a generic part number or a part number family, but the actual part number that you would put in to order this specific component. So that's been done on all of these components here, as you can see as I look through the design. So that's a brief summary of what I like to see in schematics in some of our better design review submissions. And everything I've mentioned there is really what you would expect to see in a professional project. I always try to implement those guidelines that I've just given you in the schematics whenever I deliver a finalized project to a client. And I would expect that all the designers out there should do the same. Now let's take a look at some examples of what makes a great PCB layout and some examples of some things that you shouldn't do in your designs. Here I have a PCB layout pulled up from Jacongra Nursery. This PCB layout is a 10-layer PCB with multiple internal planes. You can see here that all of the planes are very clearly named and the names are accurate in terms of how they represent the function of each of those layers. So we have signal layers very clearly labeled, we have ground layers very clearly labeled, and then we have our top and bottom component layers. Now, a lot of times the basic layout that we see in these designs is very good. Sometimes you could consolidate things onto one layer. Sometimes it's going to make more sense to put things onto two layers, and I try to mention that in these design reviews. But of course, it's never mandatory to do every layout a specific way. There are multiple factors and constraints you have to consider, and I really leave it up to the designers to figure that out. One of the big things I often look for is the Silkscreen. That comes up very often. Another thing that I often look for is, did you design all of these copper features in accordance with manufacturer capabilities? So this is a pretty good design review example that shows success in both areas. So here, if we just zoom in on some of these traces, you can see here, for example, if I select this trace, this is a 4.6 mil wide trace. Every manufacturer on the planet is going to have no problem producing a design with a 4.6 mil wide trace. Here you can see that the spacing is also consistent with what you would find with most manufacturer capabilities. If we click on the via, you can see here this via goes down to about 8 mil drill diameter, and then the pad diameter is properly oversized for this drill in order to account for drill wander. So those are all good things. It illustrates a basic understanding of both the manufacturing process as well as the manufacturing capabilities of most PCB manufacturers under a standard subtractive etch process. Now, of course, some of these lines are a bit thin. You have these two lines here that are part of a differential pair, and you can see here that these lines are 2.926 mils wide. So they are a little thin. Some manufacturers may quote you at a more expensive fabrication cost due to the more advanced etching process, but of course, sometimes that is necessary in your design. So you have to determine as the engineer whether or not that is going to be necessary for your specific design. I would argue in this design it may not be necessary. You could probably space those traces out a little bit just to increase the width. There's no need to make those traces super thin if you don't have to make them super thin. Now just zooming out and scanning around a little bit on some of these components, what I see here on these passives is a lot of consistency, which is really great. It's nice to see that these footprints have all basically been created by the same person because I see similar design standards being implemented in all of these footprints. Here you can see we have an outline for these components. We can see that we have similar type of pad shapes. We have rounded edges on these pads. And then you can see here that we have similar silkscreen size for all the reference designators everywhere. Now, even though there is consistency in the footprints, there are still some mistakes in this board. One of the big ones that we have talked about in some of our footprints videos, and I've talked about on my channel in terms of footprints, I've also talked about this with Elizabeth Bustamante on a podcast episode, is of course the embedding of vias directly into PCB footprints. In my opinion, this is a big no-no. You should absolutely not do this. And even though some of the parts in the manufacturer part search panel do come into Altium with vias embedded into the footprint, you should still edit those out because in some cases you might want to remove some of these vias to open up some more room for routing on the inner layers. So it's a good idea to keep these vias out of these die-attached pads on these footprints. Next, I want to go into 3D and take a look at the silkscreen because this is one of the more common things that comes up very often. Here, as I scroll around in 3D, we can see that most of the silkscreen is done very well on this board, but we do see some footprints that need some fixes to the silkscreen. You can see right here on U14, we have silkscreen overlapping with exposed copper pads. When I zoom out and go over here to switch 1 and switch 2, we have the same thing. We have the switch outline falling right onto the exposed pads and holes for this footprint. Now sometimes the silkscreen doesn't fall directly onto an exposed copper pad, but it does fall pretty close to the solder mask opening, as you can see here in the footprint for this test point. And we even have a little bit of a leftover line here that we should delete in the library for this component. Now, all of these points I mentioned about silkscreen embedded into the component falling onto exposed copper can be fixed using an automated tool. Now, of course, I can select one of these components. I can unlock the primitives here, and this is going to allow me to manually edit these silkscreen lines directly inside the PCB layout. But one tool that you can use that will automate all this is the silkscreen preparation tool from inside the tools menu. Inside the silkscreen preparation dialog, you can have the tool apply to all footprints or only your selected footprints, and it will basically clear out any of that silkscreen that's falling onto exposed copper. Now, if you have an issue like you see here with TP2, where the silkscreen is getting too close to the solder mask opening, you do want to check to see that the solder mask opening is not too large, and that happens inside the design rules. And I'll get into the design rules more here in just a moment. The last thing I want to mention with the silkscreen is the placement of reference designators. And I actually go through and clean up all of the reference designator placements at the very end of the design using the 3D view. So inside the 3D view with the selection filter, you can select texts only. And when you do that, you'll be able to pick up any of these reference designators in 3D and move them around like I'm showing here on screen. I prefer to do this in 3D rather than going into the 2D view and turning on just the paste mask opening and just the silkscreen layer and trying to do it that way, because when you see it in 3D, you know it's going to be accurate and appear this way in the board once it's actually fabricated. Let's take a look here at Tiga Nagraha's board, and we can see some other things that I like to see in designs. Now here we do have a net antenna error that needs to be resolved, so he's going to have to go back into the original design in order to fix that. But one thing that I do like to see in some of these designs is that you actually used the Altium tools in order to put some of these more advanced features into the PCB. So one great example here is the length tuning segments. You can see here that with the other option selected in the selection filter, if I just select this region of the board with the length tuning section, this length tuning is actually placed as a length tuning object in Altium Designer. Now you are free to draw in these length tuning sections as arcs if you want to. And I do sometimes do that when the arcs are very small. Maybe I only need one of those arcs in order to fully equalize the lengths of two different nets in the design. Another great example of using the built-in objects in Altium Designer is teardrops. You can see here on some of these pads, we do have teardrops applied. I would advise that you apply them consistently. You can see here that they haven't been applied consistently. There is a polygon region that has been auto-created and appears on this trace. This gets auto-created using the teardrop tool from the Tools menu. Now, if you thought drawing in length tuning sections by hand was a pain, try drawing in teardrop sections by hand. Nobody wants to do that. So these appear in an automated way, and you can see here that we would prefer to do this using the automated tools in Altium rather than drawing them out by hand. Now, there's one last thing that Justin Shado mentioned in his question on that design review video, and that was design rule violations. Sometimes we see dozens or even hundreds of leftover design rule violations in these boards that get submitted for a 1-minute design review. Now, a lot of times there are real violations that need to be addressed in that list of DRC errors. However, quite a few of those DRC errors can be fixed just by changing the default design rules to more realistic values. So what I have here on screen is a blank PCB. And if you go into the design and rules option in this blank PCB, you will see that we have a bunch of design rules, of course, but they're all filled in with default values. Now, these default values aren't chosen for any particular reason other than the fact that we have to have something in all of these fields, so the developers decided to fill in these numbers, right? You can't fault them for filling in something because no matter what they choose, it's probably going to be wrong. But it's your job as the design engineer to go through this list of design rules and fill in the appropriate values that match your fabricator's capabilities for building this PCB. Now, clearances and routing widths are kind of common. We've seen them in multiple design reviews needing to be changed, but I think one of the most common design rules that needs to be edited in order to make a really great design is the board outline clearance. Sometimes this rule is not used at all, and designers will draw a keep out around the edge of the board in order to enforce a clearance from the board edge. Now, there is a built-in board clearance rule. To enable it, just right-click, hit New Rule, as you just saw me do, and then you can go in here and then you can set board clearances to the edge for all objects in the design. So what I normally do is I set a 10 mil or 0.25 millimeter clearance by default in all new PCBs that I build. That's going to ensure that any copper that would extend up to the edge of the board, such as any planes you have in the design, have enough clearance to the board edge so that when the board is depanelized, there is no copper exposed through the edge of the PCB. Another very common one is solder mask expansion. I often see the solder mask expansion value is left at 4 mils wide. And in simple SMD components or through-hole components that have a lot of spacing between the pins, 4 mils is just fine. But if you look at a lot of integrated circuits, such as that have a QFN or a QFP package, that 4 mil expansion is much too large because it will leave too small of a solder mask sliver between those two neighboring pads in the package. The other thing that can happen is it will fully open the solder mask around those pads. And when you fully open the solder mask on two neighboring pads, you create a high risk of a short circuit during soldering. Now, I've said in many of these design reviews, a good value to use for the solder mask expansion in pretty much every design I've worked with is 1 mil. Why 1 mil? Well, that leaves a little bit of error for misregistration when the board is laminated and your stack up is built. That also ensures that you don't leave too small of a solder mask between pads on some of those finer pitch packages like QFNs or QFPs. Now, these aren't the only default design rules that you might need to change in your design. Go back and watch some of those design reviews and you'll be able to see some other examples of default design rules that should change in order to prevent DRC errors that aren't actually a problem when you go to build your board. Thank you, Justin Shado, for the great question, and thank you all the designers out there for sending in these design review submissions. And don't stop. If you have something great that you want to show off on the channel, find me on LinkedIn, send me your design files, or send me your manufacturing files, and we'll create a review of your design. Thanks to everybody for watching this video. Make sure to hit that like button, hit the subscribe button, leave your comments and questions in the comments section, and of course, don't forget to call your fabricator, folks. We'll see you next time.